hypotenuse up there one more time. Hypotenuse was 2. So x squared plus 1 squared equals 2 squared. What I said squared, and I wrote 4 because that is 4. 4 minus 1 is 3. You square root that thing, and square root of 3 is, well, square root of 3. Over there, same thing happened out, right? X squared plus 2 squared gives me 4 squared, right?
Sure.
Not sure. I'm pretty sure it is. Okay, what is that? 16 minus 4 is what? 12? Square root that thing. We always do simplest radical form. Square root of 12. Simplify that down. Thank you. 2 root 3. And as I said for yesterday, and the same thing is going to be true here today, there's a pattern happening. Okay? This is a 30. That's a 30. Well, I said today it's a 30, 60, 90. So, all right. Classify the triangle. What can we say for this triangle? Yesterday it was an isosceles, right? Today it's a scalene. Right. Now, the scalene part, okay, whatever. It's not as much as an isosceles right. Scalene right takes a whole bunch of different options, but it is a scalene right. All right. There's a pattern happening here, guys. If I threw out another one here, like I did yesterday with the 45, and say I did this with you. I threw out another 30, 60, 90. Let's say I made this a 5 right there. Based off of what we've seen on this one and this one, could you take a quick second, maybe find me the other two sides? Jillian?
The other leg is 5 or 7. And then 10. Yep.
We agree?
Yep.
That's good. I'm hoping you're seeing that, because if you're seeing that, then we've got the idea of the 30, 60, 90 property going on. So let's generalize that. Let's put a reference triangle together today. So in our reference triangle then, in the 30, 60, I can keep giving you more of those. So what's happening up there, all right, we obviously have what? 3 angles up there. And in these 3 angles, we're going to start with the shortest leg. What is the shortest leg? Let's go back to first semester. We talked about this relationship between the smallest angles opposite the smallest side, right? This all ties together. It wasn't just torching you first semester, maybe a little bit, but here we go. Smallest angle is 30, right? So this is opposite my shortest leg. So here, we're going to call that X. It's all built off the shortest leg. So the length of the, yes, no, you're right. The length of the, yes, hypotenuse turned out to be twice the length of the short leg. So as I look up there, from what we've seen and what then Jillian suggested to us, what was the smallest side up here? 5. If I do twice that, that gave me the hypotenuse. Twice that, hypotenuse. Twice that, hypotenuse. So if I know what the short leg is, twice that, there's my hypotenuse. That's the first one today. All built around the short leg. Okay. The length of the blank leg is the square root of 3 times the length of the blank leg. So what? The length of the long leg is square root of 3 times length of the, there you go. That's it. So what does that mean in terms of my reference triangle? All built around the short leg. So X square root of, that's my reference triangle. Just like yesterday, I gave you S root 2. Let's fill it in. Burn it. Yesterday, I said get yourself a henna tattoo. Don't give up yourself some room there. Up here, here's my 30 degrees. Now, my orientation is a little bit different. SAT's orientation is set up like this. I was checking the card just a second ago. Here's my short leg. Here's my here's my small angle. Here's my short leg. Here's my medium angle, 60. Here's my long leg. And where's my hypotenuse? That's the SAT formula sheet for you. So you should know them. Absolutely, you should know them because you're going to know them anyway. But SAT does do those two formulas. You're going to know them anyway. But there they are for you. Okay. So just as much as we've used Pythagorean theorem, you know a squared plus b squared equals c squared. By the time we get through the end of this school year and you roll through Algebra 2 next year, you're going to use them probably so much you'll get to know them as much as probably a squared plus b squared equals c squared. Okay. All right. With that in mind, let's go do it. Okay. Let's take a look down here. You want to find x. Everything is built around the short leg. You want to find x. So as we look at that first one there, the only side you know is 18. You got to match up what 18 corresponds to. What does 18 represent? It's the hypotenuse. So I'm going to get my steps in again today. When I walk over to my reference triangle, 3 out of 18 is my hypotenuse. What does that correspond to then? 2 times x. So I'm going to set that equal to 2x. I'm going to solve that out. That's going to get me x. That's going to get me my short leg. So I'm always going to set up it equal to whatever corresponds to. So 18 equals, as Carter said, 2x. And you got an itty-bitty equation to solve out. So what does x represent then? Yeah, x is 9. Now, play that game where what is the x representing again? X is going to represent what? Short leg or the long leg? It's the short leg. It's opposite the 30. Which of there is opposite to 30 then? I'm sorry? V is, right? I always like to put in the missing, if you got a missing angle up there, I always like to put it in just to draw my eyes to it. So as you said, I've got x, it's opposite the 30, so it's a short leg. Boom. I've got what? 9? And once you know the short leg, you've got everything. 9 here, and what is that long leg then? 9 root 3. It's the short leg times root 3. I don't want to say like that's it. There's going to be more to it, obviously. A little bit tougher ones, but got to know your reference triangle. Let's walk to the next one. What do you got? I'm missing an angle, right? Throw it in there. So what does that 4 root 3 represent? Thank you. That's what I want to hear. It's my long leg. So walk to my reference triangle. What is my long leg up here then? It's across from 60. Right. It's my long leg. It's across from 60. Okay, so it's x root 3. So I'm going to set it equal to x root 3. You got to know what it represents. Across from 60, it's x root 3 then. And just like yesterday, when we talked about the 45s, that's nice. That's pretty. Why is this one nice and pretty? They already got the what? It's got the root 3s on there. Okay, it's going to try to be a 4, as Deontay is alluding to. The reason why this one works out very quickly is when you divide by root 3, what happens to the root 3s? They cancel out, and this one you can really quickly tell me x is going to be 4 because this one had the root 3 on there. The root 3s cancel. You got x. Which one up here represents 4 then? Y is 4, right? Just because we have x here, please don't confuse it with the variables in the problem. I'm using that as my reference triangle. So this is my short leg, which is, as you said, here. And what is my hypotenuse then? There you go. Okay. All right, let's keep going. Let's keep rocking and rolling. Let's flip. Let's go. Up top there. I'm missing a 60, right? Let's throw it in there. This is going to get funky now. What's that 2 represent? Long leg, short leg, hypotenuse? Long leg. Let's set it equal to what? Walk it over. X root 3, yeah. You told me immediately it's the long leg. You got to know long leg is x root 3. Okay, get to know it. So maybe at the top of that paper, at the top of the notes, write this reference triangle up there so you can see it immediately. So 2 equals x root 3. This one sucks. Why does it suck? Correct. There is no 2 root 3 there. And we do enough of these, we saw it yesterday. When there's no root 3 on there, you're going to have to rationalize. And I know at some point, some of you can do that already in your head. If not, no big deal. Let's do the algebra. Divide by root 3. What happens to these root 3's? Cool. Now, with that, we talked about then, over the course, again, these last 2 months, preparing you for this step. This is rationalizing our denominator. I don't want to leave the root 3 in the denominator, so let's rationalize. Rationalize that denominator. And what do we get? 2 root 3 over a perfect square of 9. What's the perfect square of 9 give you? That is an ugly answer. But we're good to go, though. We did everything right. Now, what does that represent in our triangle? It's the short leg, right? The short leg, which in this case is what? Y. So we're going to go and put that up there. It's going to look ugly, but we didn't do anything wrong. The 30, 60, 90s tend to be the ones that kind of give you the ugliest ones because of this root 3 in that problem. The 45s, you got root 2. 2s play usually pretty nicely. 3s don't. Okay? All right, finish it off. How do we go to the hypotenuse? You multiply by, we multiply it by 2. So we're going to take that short leg and multiply by 2. So when we multiply that by 2, again, go back to fractions. You guys love fractions. Too bad. Okay, we're going to take 2 times 2 root 3 over 3. It's ugly, but we can do it. Okay, 2 times 2 root 3 over 3. Numerators. We've been doing, we did this right here. We've multiplied fractions. What is 2 times 2 root 3? Yeah, that's just 4 root 3 over 3. I mean, you did that work a few minutes ago with rationalizing. All right, it's multiplying fractions. Again, it's going to look ugly on some of these with the 30, 60, 90s because those 3, that root 3 just doesn't play nice a lot of times. Okay? That's about as ugly as it gets right here. They don't get much uglier than that. But if you can do that one, then you're solid. Okay? Number 9. Nope, sorry. 8. What does the 9 represent? Hypotenuse. So what are we going to set the hypotenuse equal to? Right. You said it's a hypotenuse. Hypotenuse is 2x. You just got to know your reference triangle. Once Cadence says the hypotenuse, you got to know it's 2x. So that's why I keep going over to that reference triangle. Plus I need the steps. Okay, divide by 2. No decimals. All fractions. Okay, no 4.5s. So x is what? 9 over 2. What does that represent in my triangle now? Now I got the 60 missing, so I'm going to go put that 60 in there. So one more time, what is that 9 over 2 representing in my triangle actually? The short leg, which is what variable then? Thank you. I got it. You got the short leg. How do we go to the long leg? Root 3. Short leg times root 3. 9 halves times root 3. What is 9 halves times root 3? Somebody just said it. 9 halves root 3. 9 root 3 over 2. Yeah, that's it. Okay. I say that's it like it's super easy. I know it's not. This is your first time through here. But you do the practice, it's not a terrible thing. It's a new one for today. Okay. All right, let's go with one more here. I'm missing the 30. I like to throw that in there. What's that 3 root 3 represent? Short leg. What are we going to go find first then, Gaten? Take one for me. Long leg. So I got the short leg. So what I have to do to find the long leg, he said. Short times what? Good. What is 3 root 3? times root 3. 3 root 3 times root 3. That's what we're doing. Short times root 3. So back to all of our work since like day 3 in here. Okay? And this is why we did everything I did with you in August. You're seeing that progression. 3 square root of 9, which is perfect, which gives me back to 9. Now what variable did we just find? Oh, not x. We found y, right? So just watch small things like that. Okay, we found y, right? And what's the last one we have to go find? And what does the hypotenuse say? Yep, 2x. Double it. Double what? Double the 3 root 3. Okay? We've got two things going on up there. So double the 3 root 3. Double the short leg. It's always the short leg. So what is 2 times 3 root 3? Correct. 6 root 3. It's all about the practice. You get plenty of practice here with that, okay? Alrighty. We're going to do a few more here. We're going to jump around. Let's go down to number 11. Okay. It's our key word to start that thing off with, number 11. It's equilateral implied. All sides are the same. What else is implied? All angles are the same, meaning all angles are the same, meaning what? 180 degrees divided by equal 3, which is all 60s. Hey, there's another keyword up there. Perpendicular, bless ya. That's not up there. Perpendicular bisector, right?
Yep.
It's a perpendicular bisector again. It goes straight down the middle, right? It's perpendicular to the base. And what does that perpendicular bisector do? Cuts it two things in half. Cuts my base in half. And also cuts what in half? The angle W in half. And what type of triangle did I just create? A 90, 60, 30? No. That just sounds disgusting. Oh my God. A 30, 60, 90. Don't ever say that again.
I'm just going to say it on purpose.
30, 60, 90.
I was just going around.
I'm gonna just go put an F in the grades on.
Hey, let's not.
Okay. I've never had somebody say that.
I'm just going around.
Oh. Okay. So with that, we are asked to find, there's the other keyword, altitude. Altitude is just the height of the triangle. So we want to find the altitude, which is what? Call that H, call that X, whatever you want to call that. That's that height of the triangle, okay? Now what do we know? We know the equilateral triangle has all the sides that are, you said equal, which in this case are all 8s, right? Now all 8s, which means also what? This 8 got, yeah, so we got a lot going on there. And you probably can tell already, but I'm going to just split this off to the side really quick. And essentially all we have is what we start off with today, which we're trying to find there, right? Back to our 30, 60, 90. So what's my height? Pretty straight. I'm going to say pretty straightforward, but you got to know that vocabulary. That 4 got to my short leg, right? And that short leg, and then that height turns out to be across from the 60. And as you guys said quickly, it is that 4 root 3. That turns out to be representing the side of the equilateral, which also represents the hypotenuse of that 30, 60, 90. So, yeah, 4 root 3. Okay? So 4 root 3 is the height of the 30, 60, 90, of the the long leg, which is the altitude of the big triangle. All right, let's do a couple more here. we get ourselves a what shape up to start up with? What shape is that? Definitely a quadrilateral.
I don't know.
It's starts with a T and ends in a trapezoid. Yes. It's a trapezoid. Okay. It's not quite as bad as what she said, but it's not around us though. Nice try there, Spencer. Okay. She's still taking the lead on you though.
It's not that bad.
Like you guys could do pretty much say anything today and she's taking the lead. All right, so on number 12, we want to go find A and B in that trapezoid. Finding A and B, we talked about in that trapezoid or in some of these shapes before. Break it into something smaller. Okay, hopefully you see we have ourselves a triangle in there, but not just any old triangle. What type of triangle is it? Right. So as we draw that in there, we end up with a 30-60-90 and what appears to be just not necessarily a square, but a rectangle. Okay. Now, on that 30-60-90, what's the one piece of information that I have? I have the 2√3, right? The 2√3, that 5 is the whole length, that I don't know anything to go with that 5, because that B I don't know, but the 2√3, I'm going to slide that on over, which works for that 30-60-90 now, right? So, again, it's getting a little messy. I like to bring things off to the side, kind of condense that down. And there's another 30-60-90 that we've been finding all the sides on. Let's go find the sides. One more time. What's the 2√3 represent? Yep, long leg. What does that long leg represent over here? Across from 60, which is x√3. Correct. So you got again. You can't play the magic game. You're dead in the water there. So 2√3 equals x√3, and that's a nice one. That's a quick one because they are √3s. So you should be able to tell me x is what? 2, because the √3s are going to cancel out, aren't they? So where's that 2 going to go then? It's a short leg, right? It's across from my 30. And as I'm filling out that triangle, the hypotenuse is, right, hypotenuse is 4. As we slide that back into our trapezoid then, what variable do we just find immediately? Yep, we found A as 4. So what's B going to be? B is what? Oh. B is 3. So this is 2, A is 5. Hold on there. This is 2, right?
Yeah.
This whole length is 5.
Yeah.
B is right here.
Yeah.
So 2 plus 3 is?
5.
Yeah, B is just 3. It's not 2√3. I'm done.
Hey, I said 90-60-30 confidently.
So,
like,
right there, that 5 is 2 and 3 together. That's where that 3 is coming from, not 2√3. Okay, it looks like a square, but we don't know it's a square. We don't have the information on that. It turned out to be not a square anyway. Okay.
Nope.
All right, one more here.
Okay.
All right, down here, let's bring in number 14.
Oh, okay, that's easy.
Okay, on 14. 14 brings us to blending the two together from yesterday. As we've done before, even before yesterday, with Pythagorean theorem, we've had to split these apart and find that shared side. So let's call another variable out there for that shared side. And we're starting off with the 45. So on that 45, 45, 90, this is usually where we have kind of a step back sometimes. Going through individually yesterday and then just today by itself is usually okay. But once you guys get to going on your own, this is where kind of we get things intermixed. What do I mean by that? Our 2 triangles here, reference triangles, they just kind of get blended for some of you. Those hypotenuses, some of you kind of blend those together. What I mean here is sometimes bring in this root 2 here, or bring that root 2 down here for the long leg accidentally, or say this is 2x over here. So I'm not going to be surprised to see we have a bit of a backslide here just because these somehow need to intermix. So do your best to try to keep those separated there. What do we have here? On the 45s, what's my y going to represent? Correct. It is going to be 7 root 2 because in the 45 triangle now, from yesterday, that is s root 2. It's the leg times root 2. So these two legs we said yesterday are congruent, and that's isosceles right triangle. So as you said, it's just a leg root 2, 7 root 2. Okay, that links me together now, and in that 30/60 now, we have what? The 7 root 2 here, right? What does that 7 root 2 represent?
The short one.
That's nice. If you get the short leg, that's where we want to be. And what's the variable represent up there?
Hypotenuse.
It's the hypotenuse, correct. So as you told me, we got the short leg, great. We want the hypotenuse, so we just got to double it, don't we? So take it and double it. And what is 7 root 2? Doubled.
14 root 2.
14 root 2. So blending the two triangles together, nothing to say like super crazy, but split them apart. I would encourage you to split them apart like we've been doing. All right, it's a composite figure, kind of like what we did a second ago with the trapezoid. All right, do your 45 or do your 30/60, whatever you need to do first. Find that linking side, and then do your second triangle, whatever you have to do there. Okay. All right, you got some time today, work. Today is again on there, online.